There we go. Yeah. Don't have your camera, but that's okay. Don't worry about it. Okay, I'm going to share the screen. I was just going through the special triangles to see if there's a way I can send you a video in case you don't remember how to do the special triangles.
Okay.
So what I'm going to do is I'm going to race through all three sheets here,
Yeah.
and you're going to stop me when you don't get something. Okay,
Okay.
here we go. When's the test?
Is Tuesday, next Tuesday.
Oh, great. So if you want to schedule another session,
Yeah.
Thursday night or Saturday or Sunday,
Hmm.
let me know. Saturday, I need to
Yeah.
know in advance though.
Okay, I'll send you a text before, yeah,
Yeah.
because probably that's probably what
Yeah, because
what I should do,
yeah,
yeah.
cramming in the night before is never a good idea. So Monday's our next session. So
Yeah.
what is the reference angle for 168? So for the you always just say, "Oh, I know that," if you just know it, okay? So don't just stop me if you know
Yeah.
it. But for the reference angle of 168, you always have to draw the Cartesian, go all the way here and say, "Okay,
Hmm.
that's 168."
Yeah.
Therefore, the reference angle is the one that's closest to the x-axis right here. That means it's always going to be 180 minus 168,
Yeah.
which is 12. So
Yes.
the reference angle that we're thinking about is 12.
Hmm.
This is the terminal angle, and we used to just call this the acute angle, but the reference angle makes sense as well.
Okay.
Okay, so very basic. Identify a positive angle coterminal with the standard angle of minus 115. You might say, what the hell's a minus 115 angle? When you go this way, this is the way we're supposed to do it, except for bearings, but for
Hmm.
Cartesians this way. And when you go this way, it's minus. So when we're going this way, it's minus. So that's minus
Yeah.
90. And to get to 115 from 90 is another 15 degrees. So there's 115. Wait, let me just make sure 115 was what they, yeah, 115. So
Hmm.
from 90, we got to go 25 more. So 90, and then 10 more is 100. 10 more is 110, and then 5 more is 115. So 90 plus 25, that's negative 115. A
Yeah.
coterminal angle is any angle that ends up in the same spot. So any angle that ends up at this same terminal arm here. So if
Hmm.
I went the other direction, boom, 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 until I hit that arm, it would
Hmm.
be 360 minus the 115. So it would be 245 is the equivalent. So
Okay.
180 plus another 65. My question to you is,
Hmm.
do you understand how I got that? So minus 115 that way,
Hmm. And then, yeah.
and it's
Okay.
225 this way because the whole thing is 360.
Yeah.
And to
Okay.
share 115 with 360, it's 245. So that means
Okay.
the a coterminal angle is an angle that ends up in the same spot.
Oh, terminal. Okay.
There are thousands of them. I could just keep going another 360 and I get minus
Hmm.
475, and that's also coterminal. I could go
Yeah.
360 on top of that and it ends up in the same spot.
Okay.
So there's thousands of coterminals, or
Yeah.
infinite. I shouldn't say thousand, infinite. Okay, determine the exact value. So when you see exact value or when you see decimal, so here's a hint. You see nearest degree on this next question, right
Hmm.
down there.
Yeah.
So when you see nearest degree, that means calculator.
Okay.
Okay. When you see exact value, it means you have to use your special triangles.
Hmm.
So let's look at where 300 is. Ready? Here we go. 90, 180, 270, 30 more is 300.
Yeah.
What's this angle here?
It is what?
How much in a full circle?
360?
If I went 300 to here, how much is
Oh,
left?
60, 60,
60. So
60.
that's the special angle we're looking for. What quadrant are
Mm-hmm.
we in?
4.
So what's going to be positive? Where would I do my cast? What goes here? What letter goes here for cast?
C.
C. So that means
So,
cosine is positive. Everything
yeah.
else is negative. So let's go back to
Uh-huh.
the question. So that's the logic you have to look. I need an exact value for 60. I have to look up cosine. So we're going to go back to the
Okay.
question and say, what are we looking up? They say they want to know the exact value for this for sine. You see, it says sine. I want to
Mm-hmm.
try to make this. There we go. For
Yeah.
sine, they say sine right there. So we know that
Hmm.
sine is going to be what in that quadrant? Positive or negative?
That is negative.
Right. So whatever answer we get, we got to slap a negative in front of it. Now
Yeah.
all we got to do is figure out what's 60 because 60 is the one that we should be able to memorize. This is where we take our special triangles, and you have to practice because there's a later question, or
Hmm.
even this question that explains how you came up with it. This is a
Hmm.
triangle with equilateral sides. That means they're all the same size. When you have an equilateral sides, you have equilateral angles. That means every angle is 60.
Yeah.
Okay? That means if I slice this triangle in half and get rid of half, I'm left with one side here that's only one length, one side
Hmm.
here that's only two length. I won't know this one because it's
Yeah.
down the middle of the triangle, but I know that this is 90. I know that
Hmm.
this is 60, and that
Hmm.
leaves this one 30. Well, fortunately,
Yes.
I'm looking up 60. So sine of 60, according to SOHCAHTOA, is what? What over what?
S O over 8.
Yeah,
So
O over H. So it's
2
opposite.
over.
No, it's opposite from the
Oh, okay.
60.
Yeah.
Opposite
Over
over
2.
hypotenuse.
Yeah.
So we would need to figure this out. With the Pythagoras theorem, you can figure it out. It's this squared plus this squared is equal to
Hmm.
that squared. So it's 1 plus we don't know. Let's just call it x. We don't know. Is equal to 2 squared, 4. So
Yeah.
x squared is equal to 3, which means x is equal to the square root of 3. So that means this side here is square root of 3.
Hmm.
So I'm just racing through. You stop me if you don't get it.
Okay.
So that means this side here is square root of 3. This angle is 60. So that means the sine of 60 is going to be the opposite over the hypotenuse. That's SOHCAHTOA. The
Hmm.
hypotenuse 2. The hypotenuse 2. The opposite side is square root of 3. So I take my little square root of 3, which is whatever. It doesn't matter if it's drawn lousy. And there we go. I put that where the opposite. So we're talking about the fraction square root of 3 over 2. And we already figured out it has to be negative.
Yeah.
So that's my answer. That's an exact value because it's a square root without decimals.
Okay.
Over 2 with a negative slammed in front. Your teacher will want to see you come up with that. Your teacher will want you to understand SOHCAHTOA.
Hmm.
And he'll want you to be able to figure out that it's negative because of the quadrant of 300. Good?
Yes.
Okay. Going back to the questions. Here we go. This is an exact value question. When you see exact value, you got to use nearest degree rather. So not an exact value,
Hmm.
nearest degree, and include a diagram for full marks. So let's look. First of all, they're talking about tan, so we got to keep that in mind. But when we're talking about nearest degree, we do not have to use the special triangle that I just used. Okay.
Hmm.
We instead have to use our calculator. So I didn't quite get that. So I'm going to go back up here and try again. Yeah, that's good enough. It's right there. So we don't have an angle. We don't have an angle. But I want you to be aware that when there's angles like this, there's almost
Hmm.
always two angles. Why? Because if I put my Cartesian graph and do my cast like that,
Hmm.
I can see
Yeah.
sine is positive here, but sine is positive there. Therefore, there's
Hmm.
two possible signs that are positive. Down here, sine is negative and negative here, so there's two possible angles that are
Hmm.
negative. Here we're talking about tangent. Since tangent's positive here and positive
Yep.
here, we're talking about these two possible quadrants, not there and not there, because that's where they'd be positive. I can see over here there's a negative number. So that
Hmm.
means I'm talking this quadrant or this quadrant. Your
Okay.
calculator, sadly, will always spit out the angle that's closest to this starting point. So your calculator is going to spit out this down here.
Hmm.
So when we start here and go all the way around, it's further to get here than it is to get here. So your calculator
Yeah.
is going to spit out the closest quadrant to where we start, either this quadrant or this quadrant. Okay?
Yeah. Yeah.
It's annoying. You have to know what your calculator is going to spit out. The nice
Mm-hmm.
thing about nearest degree is we can just take our calculator and do arctan to figure out what angle we're talking about. So we're going to
Mm-hmm.
take our calculator and we're going to take, if I'm going too fast, just say, no, you got to stop and go back. Okay.
Okay. Yeah. Yeah.
So I
Yeah.
take my calculator, I put the thing, the tan that they've told me, and I go to my trig and I do
Mm-hmm.
arctan to get the angle out of it.
Yeah.
So
Mm-hmm.
when I do arctan, I get this angle. Notice the angle's negative, just like I predicted. It was going to spit out this quadrant here. Negative is this way. That's
Mm-hmm.
what this negative angle means.
Yes.
Okay? So that
Mm-hmm.
means my calculator has told me this. Negative 39. Negative 39 is going this way. I'm just going to lower this a little bit. There we go, like that. Negative 39 is going this way. Negative 39. It was a lot of zeros too, so I'm not going to worry about
Yeah.
rounding up. So really we're talking about negative 39.
Mm-hmm.
But your teacher wants this angle. He doesn't care about the negative direction.
Yeah.
So the first angle I've got to figure out is this one.
Mm-hmm.
What is the blue angle? If the whole thing's 360 and I go back 39.
321.
Yeah. So that's the first angle. To
Yeah.
confirm, if you're worried, oh, did I get this right? Did I remember listening this correctly? If we take 321 in our calculator and we hit tan, we should get the number that they've asked in the question. Negative
Mm-hmm.
8, negative 0.8097. It's
Mm-hmm.
98 because it's rounded up. Doesn't matter. We got the number. So this
Yeah.
one is correct. 321 is a correct answer. It gave me this negative answer. But 39 is the acute angle between the x-axis, right? 39. Remember I
Mm-hmm.
said it's this quadrant and which one? Which other one did I say it was?
Oh, that one across from it.
Yeah, over here. So it's really this here with this angle here,
Yeah.
39. Well, the question is, if that's 39 between the x-axis and that blue bar, how much is this angle here in red?
141.
Yep. So 141 should be the other one, the other answer. So just to
Mm-hmm.
confirm in my head, before I move on to the next question, if I punch in tan of 141 here, I should get the same number again. And I do, negative 0.80978. Yeah, it's not quite right because we've rounded up, rounding errors, but I'm confident that I got the two right answers. The two right answers are 141 and 241.
Mm-hmm.
Good?
Mm-hmm.
He wants this, include a diagram for full marks. Don't forget that he wants it to 1 degree. So even though I used minus or used 39 here, the correct answer is 141.0, 241.0, because that's to 1 degree.
Okay.
He'll take marks off.
Yeah.
Most of them do. Okay?
Yes. Okay.
So it's a whole bunch of little things to remember.
Mm-hmm.
Good so far?
Yeah, pretty good so far. Yeah.
Good. This is one where it's neither the exact triangle nor is it a calculator. It's just drawing triangles, number 4. These are all very common questions that you'll see in almost any trig test.
Mm-hmm.
Okay, and I'm just going to raise it up. I'm going to get rid of, no, I'm going to keep that actually. Just going to raise it up to there. There we go. Here they've given us a point, so we might as well draw it and figure out where it is. Right? Here's the Cartesian graph. They've given me the
Mm-hmm.
point 0.9.
Yeah.
That's kind of mean actually to give. I'll let you know right now to give zeros the first point is really annoying. But so we're
Mm-hmm.
going way out here. Zero's the x value. Oh, sorry, zero's the x value. So we're actually going way up here.
Mm-hmm.
0x and 9y is right there. So we would draw a little picture. We'd add the label. Okay.
Mm-hmm.
This one's actually easy. It's annoying that they've done it. But that's how much from beginning here to that point. How much is this angle?
Mm-hmm. Um, what? I don't know.
Well, you should. So I'll let you know from x-axis to y-axis is 90.
Yeah.
From this y-axis to the
Mm-hmm.
next axis is 180 total. 90 more. from
Yeah.
this x-axis to this y-axis is 90 more,
Yeah.
270, and all the way
Uh-huh.
around is 360. Doesn't matter how
Yeah.
far up this point is. To get from here to here, the angle here is 90 degrees,
Oh, yeah. Okay.
right? Doesn't matter
Yeah.
how far off I am.
Mm-hmm.
Okay, so do you
Good.
remember on my original unit circle, what were the 4 points? What were the 4 points? Here, here,
There.
here, and here. What's this one here?
1, 0.
Yep. What's this one here?
Mm-hmm. 0, 1.
Yep. What's the one on the left?
-1, 0.
-1, 0. And what's the one at the bottom?
0, -1.
Great. The only thing I need you to remember, well, one, that this represents 90, right?
Uh-huh.
This
Yeah.
represents 180.
Uh-huh.
That one at the bottom represents 270.
Mm-hmm.
The one over here represents the starting point, which is 0, but also represents the finish point, which is 360. Now,
Yeah.
here's the other thing I want you to remember. All the x values, they represent the cos values for that angle. All the y values in those coordinates, they represent the sine values for that angle. As an example, at the 0 mark, cos of 0 is equal to the x value, which is 1.
Yeah.
Sine of 0 is equal to the y value, which is 0. And
Okay.
it's right here. Here's the x value,
Yeah.
and here's the y value. Same for up
Okay.
here. Same for what up here. So if x represents the cos value and y represents the sine value, what's the sine of 90?
The sine of 90 is 1.
Yep. So
Yeah.
the answer to this,
Is
1.
1. Okay.
Bit of a trick
Pretty easy.
question because he put it right on the y-axis. Be
Yeah.
aware that he won't often do that. This is just kind of a trick question. That's why you can always look at the marks and say, oh, it should be a fast answer.
Yeah. Okay.
Okay. Often
No.
they'll put the point here. You'll have to draw a triangle. You'll have to figure out the height, the length, and figure out all from SOHCAHTOA, figure out all the angles.
Yeah.
We'll probably see a question like that.
Okay.
Okay, so now we're jumping. I notice this review also has a mix of quadratics in it. So,
It does. Yeah.
yeah. So this one, next one's worth 3 marks, so there should be a little bit more work in it.
Mm-hmm.
Here we go. Let's just do that. And this and this. So this one, it looks like we have to draw a triangle. It looks like they give us 3 lengths. Length, length, length. So we're just going to draw a random triangle. We're going to say, okay, there's one line. That should be about the same length as that line. And then there's a real long one.
Mhm.
Okay. So we'll call the
Yeah.
real long one 17.
Mhm.
We'll call the second longest one 11. And we'll call the shortest one this. Now those little
Okay.
letters also tell you the angles on the opposite side.
Yeah.
So we're the
So
corner. Big P,
big P. Yeah.
big R,
Big R.
and finally big Q. They want to know, determine the measure of angle P to the nearest tenth of a degree. So it's 2 decimals.
Yeah.
So you're like 10.23. That would be to the 10th. Oh, nearest tenth of a degree. Sorry, that's nearest hundredth. Nearest tenth is the first decimal. Okay.
Okay.
Now, when they give you, here's something you just have to memorize. When they give you 3 lengths, you have to use the cosine law.
Yeah.
So that means we have to pull up the cosine law that has the angle in it. So we're going to go back. I don't know what that is. What's that? Going to go back up top. He's given you some of the formulas up here. And this is the one we've got to use. The one that has the angle on the left. So we're going to use this one. But the problem is this formula doesn't quite match the letters I'm using.
Mm-hmm.
And since we're looking for angle P in the question, that's probably what we're going to be calling this thing here.
Yeah.
So we can
Yes.
start with replacing that with cosine P, which means the little
Mm-hmm.
a will be little p.
Mm-hmm.
Once you figure that out, these don't matter. It doesn't matter which one
Okay.
you assign because they're all squaring and being added and being
Yeah.
multiplied. So that means I can assign the 11 to here and the
Mm-hmm.
17 to here. Sorry, no, the 17 has to go with P over here,
Mm-hmm.
and the 9 can go here. Did you follow
Okay.
that?
Yes, that makes sense. Yeah.
Okay, they're looking for P, so that means this one here has to be with the A in the formula and the A
Mm-hmm.
in the formula. Good?
Yeah.
So that
Yes.
means I have to fill out where I see B, doesn't matter which one I use. I can use the 11. Where I see C, I can put the 9. Down here, it's going to be 2 times 11 times 9. And where
Yeah.
I see A, I have to put the 17.
Okay.
We're not going to worry about doing formulas or using calculators here. 11 squared is 121. 9 squared is 81. And then it's going to be
Mm-hmm.
minus whatever 17 squared is, which I really honestly can't remember at this point in the day, is 289. So that's what we're going to have deal with up top. So it's going to be a negative number. Down below, we have 9 times 11, which is 99, times 2, which is 198. Down
Yeah.
below, we're going to have 198. So really all I have to figure out is what the top is, 198. With me so
Okay.
far?
I am. Yes.
Okay, so up here it's going to add up to 202 minus
Mm-hmm.
89, minus 289, so it's going to be minus 87, 202.
Yeah. Okay. And
Okay,
then yeah.
so I got minus 87 divided by 198. So it's going to
So,
come out as negative, right? So I'm going to
yeah.
got minus 87 divided by 198. There we go. And I get this number.
Yeah.
So I'm going to copy most of it. So ultimately, this is what I end up with. The cos of angle P, the cos of angle P is equal to this number. What do I do?
Inverse
Yep.
sine.
Inverse, almost.
Inverse the cos. What do you call it? Inverse.
Cosine.
Inverse cosine. Yeah.
Yeah. So
Okay.
when the cosine law, you got to do inverse of cosines.
Yeah.
Okay, so we
Okay.
got this. I go to my trig. I hit the second. I hit in cos to the negative 1. And I get this. We're almost done.
Mhm.
That means angle P is equal to this. Now, how many tenths of a degree? So that's the first decimal.
Yeah. So it's just 0.1.
Yep. And then don't forget degrees.
Okay.
Okay, or the little circle.
Yeah.
So he wants to see all this for 3 marks.
Mm-hmm.
All right.
Okay.
There
Yeah.
are some cases where there's 2 triangles. You'll have to practice those. This is not one of them.
Mhm.
When it's side by side by side, there's only one possible answer.
Okay.
Good?
Yes.
At any time, Aiden, in any of these lessons, stop me and say, you got to go back up.
Okay. No,
Okay.
that
Yeah. No,
those ones
I'm
make
sure you're
sense. Yeah.
following. I'm just saying, sometimes it's too fast.
Oh. Yeah.
Okay. We have a terminal arbiter, so we know that the sign is this. So let's ask ourselves what they tell us. Before you ever tackle a question, say, okay, what do I know for sure? Well, I can see that we're trying to find the exact value of a tan of an angle. We don't
Mm-hmm.
know what the angle is. We just know it's in a standard position. Just don't worry about that. In quadrant 2, where's quadrant 2?
Yep. That one.
With the here?
Mm-hmm.
Yep. So we'll just slam an arm there. Okay. Now let's
Yes.
go back to SOHCAHTOA. SOHCAHTOA. What does the sign mean? The S, the first
Over
letter.
H.
So
Over
sine
H.
of any angle is going to be equal to O, which is the opposite side,
Mm-hmm.
over the hypotenuse, right?
Yep.
Now notice that they've given us the sign here. They've given us, that's the other piece of information they've given us. They've given
Mm-hmm.
us the sign. Well, if it stands to reason that the sine of the angle is equal to the opposite over the hypotenuse, right?
Yes, and that means
What does this mean? What does it mean, man? If this is
that the hypotenuse is like blue line,
no,
and then
yes, that's right. This is definitely the hypotenuse. But what does this number tell us in terms of this?
the what the numbers are, like what the opposite
Yeah.
side is,
So
like
the opposite
hypotenuse is,
is?
yeah, is 2,
Yeah, and the hypotenuse is?
3.
Great. That means I can slam a direct line straight down to form a triangle. And since this is always the angle, right in here, this is
Mm-hmm.
the angle we're going to find. This is not the
Yeah.
terminal angle. This is called the acute angle or the reference angle.
Mm-hmm.
We know that its opposite side is 2 and its hypotenuse is 3. What don't we know?
Yeah. That side, which
A.
is adjacent.
Yeah,
Yeah.
we do know a squared plus b squared is equal to the hypotenuse squared. We
Yeah.
know the hypotenuse is 3. We know b is 2. So
Mm-hmm.
3 squared is 9. 2 squared is 4. So we know a
Mm-hmm.
squared plus 4 is equal to 9.
Mm-hmm.
Help me solve. A squared.
-4.
Yep. So a squared is equal to 5.
Yep. Then square root.
Yep. So that means a must be the square root of 5. At
Mm-hmm.
this point, I can figure out what the tan is of this angle. Tan in
Mm-hmm.
SOHCAHTOA is TOA. What does that stand for?
Over A.
Yeah, and what's the O mean?
Opposite over adjacent.
Yeah, so here's the opposite. Here's the
Mm-hmm.
adjacent. What's my TOA equal to? What's the tan of this
Um,
angle equal
2
to?
over square root 5.
Yeah, now there's only one little trick that you'll lose marks on. What quadrant are we in?
We are in second one.
Second one. So C, A, S. What's positive in that quadrant? S.
Sin.
Is this a sin? Is tan a sin?
No, so it's negative.
Yeah, there you go. You got to slam a negative in front of it.
Okay.
A lot of students will miss that. You lose half a mark and you go, oh, fuck. It's not worth
Yeah.
losing it. Always
Mhm.
get the easy
Okay.
marks. Say,
Yeah.
okay, there's probably more. So they want to know what it is. So we would say it's negative 2 over square root of 5 down here. And he,
Okay.
he obviously, okay, so that's the first page. That wasn't too bad.
No, that wasn't too bad. No,
All
no.
right. Second page. I think I got it here. This might have been the first page. Doesn't matter. All right. So reference angle again. Go. Or did we do that one? I think we might have done that one. Cos 210. Yeah. Did we do all this? I think we did all this, didn't we?
Um,
Let's see. No, we didn't. Okay, good. Let's go. We just did that one. All right, here we go. Very similar questions.
yeah.
All right. So they want an angle. They want two other standard position angles that also have this reference angle. What's a reference angle? It's a thing I call the acute angle. So we're going to draw our reference angle here. We're going
Yeah.
to start with the Cartesian graph. Now we're going to keep the same color. There we go. We're going to
Mhm.
go up 75 degrees. 1, 2, 2, 2, almost 90, right? So
Yeah.
we're going to draw a straight line there, sort of 75. Now, the secret is that in these other quadrants, a 75 degree exists. Over
Yes.
here, it's always going to be the angle between the x-axis and my new
Yeah.
terminal arm. So there's a 75 here, there's a 75 here, and there's a
Mhm.
75 here. But those aren't 75s. That's the only one that's 75. Let's look at the first one, or the second one. That's my main one.
Yeah.
Over here, if the angle is here, 75, we want to know a terminal angle, which is this angle here.
Yes.
What's the terminal angle?
It is 105.
Yep. So always in this quadrant, it's always 180 minus that.
I think what messes me up on the
Yeah.
tests is like the terms because it's
Yeah.
like
Yeah.
when we're reviewing it, I don't really read the well, I read the question, but like,
Yeah.
you know,
So
it's
this little
like
angle in here that I've called acute angle a lot is the
yeah,
reference angle.
reference angle.
This
Okay.
here's the one they always want. It's called terminal or standard.
Okay.
Um,
Terminal
yeah.
standard.
And that's the one they
Okay.
always want. They'll always give you, well, sometimes they'll give you this one and ask to find that one. But it's usually finding this one and then figuring out these ones.
Yeah.
Now, that's
Okay.
one of them. In this quadrant, it's always 180 minus that angle that we figured out. Over here in this
Okay.
quadrant, it's always 180 plus the angle. So if we got 75,
Hmm.
what's the full angle? 180 plus 75 is?
Is
180. So 7.
255.
Yeah, you got it. So your math's getting better. So that means
Mm-hmm.
in this other quadrant, if I was to slam the 75-degree angle here, it's obvious. I go 180 plus another
Mm-hmm.
75, 255.
Yeah.
There.
Yeah.
We came up with the
Mm-hmm.
two of them. The last one is always 360 minus the angle. So the
Yeah.
last
Okay.
one is 285.
Yeah.
Okay. But they only wanted
Okay.
two. So just give them what they want.
Okay. Okay. Yeah.
Okay. Good. Here's another exact question coming up. So whenever you see exact, that means you have to use your special triangles.
Okay.
So it's a lot of little rules to remember, but it's the same technique for the little
Yeah. Yeah.
rules. So when we do exact values, we need to find that little angle. So in this case,
Okay.
they've given us the terminal angle. I can tell because it's more than 90 whenever the angle is
Mm-hmm.
more than 90. So I go 90, 180,
Mm-hmm.
270, 300. So if
Threes.
I've
Yeah.
gone 300, I've gone all the way to there. How much is
Mm-hmm.
left?
60.
Right. So that's our special triangle that we're interested in, 60.
Yes.
Good?
Yes.
Okay. So they want the sign there. What letter goes in this quadrant? We're in quadrant 4, in the cast.
Um, D.
C. So is sign positive in that quadrant if there's a C there?
No.
So just remember, we're going to have to slam a negative in front of whatever our exact value is for 60. We already
Yeah.
drew that triangle for 60. The top corner is 30, but the bottom angle down here is 60.
60 and
And
30.
we already
Yes.
figured out that this tall part here was square root of 3.
Uh-huh.
This is 1, and that's 2. We did that just a
Okay.
second ago, remember?
Yes, I do
And
remember.
if you
Yeah.
need to come up with 30, there 30 is up there. That's the
Mm-hmm.
opposite to 30, and that's the hypotenuse. That's the
Yeah.
adjacent to 30, and that's the hypotenuse. But we want sine of 30. What's in SOHCAHTOA? What does the OH stand for?
Over H.
So it's O over
So
H, so the opposite is?
is square root 3 over 2.
Yep, that's right. So that means it's square root of 3 over 2, but we slam the negative 2 into it because we're in quadrant 4, which means
Yeah.
sine of 300 is equal to the negative square root 3 over 2. That's the answer.
Yes. Yeah. Okay.
Make
Okay.
sense? So
Yeah,
the
that
tough
wasn't too
part is
bad.
just
Yeah.
coming up with the special triangles because that's what he wants. He wants to include a
Mm-hmm.
diagram for full marks right there.
Okay.
Okay. He also wants to see how you came up with the 60 degrees.
Mm-hmm.
300 to there, left over is 60.
Okay.
Good. Now it could be that
Yes.
he also might give you the table. Always page through the whole test and see
Yeah.
if he gives you some tables in the back. Because it
Uh-huh.
could be that in the back he gives you these tables here, the exact values. So
Okay.
60 right there for sine is square root of 3 over 2. Once you do all your little special triangles, you can make a table like this. I recommend it as if you have to draw a special triangle, mark down
Okay.
the values and fill up this table. And that
Mm-hmm.
way you don't have to keep drawing the special triangle. Right? But also page through any exam you take, sometimes he gives away information in later questions. Right? And you go, oh, there's this table, special table. He might say, you might ask him, do I have to draw the triangle? And he'll say, yeah, you do.
Okay.
Right?
Yes.
Okay, let's go to the next one. I keep clicking on the wrong ones here. That's true. I somehow skipped. Oh, you know what? I went to the wrong page. Sorry. Doesn't matter. It's all good. It's all good practice. I think we already
Yeah.
did that one from the other question. So this one, notice right away that there's a long
Mm-hmm.
decimal to negative. Right away, you should say that is not an exact triangle.
Yes.
Okay, so that means my
Okay.
calculator. What are they asking? Two possible angles. Notice there's a negative number here. The number they're
Uh-huh.
giving us is negative 0.9205. We're going to draw our Cartesian graph. Buy yourself some headphones. Really helpful. Cartesian
Yeah.
graph. C,
Mm-hmm.
A, S, T. Where is sign negative?
Sign is negative on the C and the
Yep,
T.
that's right. So that means we're going to be dealing only with these two quadrants. So now I
Yes.
just need to reverse arc sine my calculator to get the angle. But remember, it's going to give you the answer that's closest to this bar, which is that one.
Yeah.
It's going to give
Okay.
us a negative angle answer. So I'd
Yeah.
pull out my calculator. I put my 0.9205. I'd make sure it's negative, and I hit arc sine.
Mm-hmm.
And it gives me this negative angle. Negative, it's pretty sure we're going to round it up just to save our lives here. We're probably going to use, instead of that, negative 67, right?
Yeah. Okay.
Because it's
Six.
it's
Yeah.
it's
67.
it's
Okay.
pretty damn close.
Yeah.
So negative 67. Well, so that, no, there we go. So that means since we're negative, we're going this way,
Mhm.
and they're talking
Yeah.
about this angle right here, 67 degrees.
Yeah. Yes.
But
Yeah.
that's not the terminal angle. That's the reference angle or the acute angle. The terminal angle starts at the beginning and goes all the way around and ends there. So what's the terminal angle? If that's 67,
It's 360 minus 67.
yeah, so I'll help you out. It's 293.
Okay.
As long as you could tell me that part, I'm fine with it.
Yeah.
So
Okay.
293, that's our first one. But remember, there's another one over in this quadrant. Remember, we check marked this quadrant?
Oh yeah. Yeah.
So you have to draw a little
Mm-hmm.
terminal arm and put a 67 between the terminal arm. This is
Yeah.
always called a terminal arm. This is called the terminal angle. It's all the way to that arm. So this
Yeah.
67 is between the terminal arm and the x-axis always, which means the terminal angle is all the way to here plus
Is
that.
247.
That's a 7. You
Yeah.
got it. 247. And if I wasn't sure, I would just take 247 in my calculator and hit sine, and it'll spit out this number up here.
Okay. Okay.
Boom, I know I got it. It's like instant. And if I
Mm-hmm.
spit out the other one we did, which was whatever it was, 293, it would also give it
Mm-hmm.
to me.
Okay.
Okay,
Yes.
good. Or
Yes.
it wasn't 293, it was some, whatever. Yeah,
Mm-hmm.
293.
Yeah.
Great. Next one. Number 3. Notice the words in number 3, exact value. That means I have to use my.
Special triangles.
That's right. So we need to figure out what the little reference angle, acute angle, is for 210. 210 is this. We go 90, 180. How
Mm-hmm.
much more to 210 if this is 180? And I want to get to 210.
Little bit.
Yeah, 180 to
Like
210 is how far?
it's 30.
So now this time we're looking for the angle 30.
Yes.
Okay, good. They're looking for the value of cosine, C-A-S-T.
Mm-hmm.
What can you tell me about cosine in this one?
It is negative.
That's right. So no matter what, I'm going to slam a negative in front of my answer. I'm looking for
Yes.
30. Fortunately, I drew that triangle when I drew the 60.
Yeah.
When I drew the
Mhm.
60, I had square root of 3 here,
Yes.
1 here, 2 here, but the 30's
Yeah.
up here. In SOHCAHTOA, Ka, C-A-H, stands for what?
Oh, A over H.
Yeah, that's what cosine stands for, A over H.
Yes.
What's the A to this 30 degrees?
It,
So if that's the hypotenuse over there, because it's opposite the 9.
oh no.
Yeah.
It's square root of 3.
Yep. And what's the hypotenuse?
2.
Right. So the answer to cosine value of 210 is the square root of 3, negative square root of 3 over 2. And keep in mind the negative has to go outside the square root. Don't be tempted to put a square root of 3 with the negative inside of it. The negative that we find from this quadrant goes outside.
Uh-huh.
Good?
Yes, good, yes.
Yeah. This is easily proven with the calculator. You'd have to take a few extra steps. You'd have to go square root of 3 divided by 2. It's equals, and then you'd have to make it negative. Let's see, negative, where am I? There we go. And then you'd have to hit, okay, what's the arc cosine of that? And it'll spit out, it spit out 150, which is fine because that's the nearest angle where we're going to get that answer.
Yep.
Which is over here, 150. So my calculator always spits out the nearest 1/150, even though
Mhm.
210 counts because it's over here. It spit out this
Yes.
one up here.
Okay.
And that's where the calculator is a bit annoying. It'll always spit out the closest one, not both of them.
Yeah.
Good questions.
Hmm.
Good.
Pretty good, yeah.
Okay, that was 210. Find all possible values. Now this goes back to our 60-degree triangle, and I'll show you why. You might say, okay, I can see it's an exact value. It's saying they've given me square root of 3 over 2, and that sounds so familiar. And that's because we drew our 60-degree triangle a few times now. And our 60-degree triangle had a square root of 3 over here.
Yeah.
It had a 2 here. It had a
Uh-huh.
1 here. It had the 60 here. It had the right angle here. And it had
Yeah.
the 30 up there. Sine.
Hmm.
Sine, they've given me a sine. So sine in SOHCAHTOA stands for
Over H, so it would
opposite
be,
over h. So the
yeah.
opposite to 30 is 1 over 2.
Uh-huh.
No, no. The opposite to 60 is square root of 3 over 2.
Oh.
Yes, yes.
Uh-huh.
Right? So
Yeah.
that means in this question, we're talking about 60 degrees.
Hmm. Okay.
However, this is positive, isn't it? This answer is
Yes.
positive.
Yes, it
So
is.
that means it's CAST. Where's sign positive?
In the S and the A.
Yeah. Well, your calculator, the 60 degrees that we figured out is right there.
Yeah.
So we just need to figure out the other one.
Okay.
Do. So we figured out this one. 60 degrees, the easiest one.
Yeah.
But we need to figure out this one over here. The acute angle is 60 between the bar and the terminal arm and the x-axis. But
120.
there you go. Both sine of 120 and sine of 60 will yield me this result.
Okay.
Make sense?
Yeah, that makes
Yeah.
sense.
Once you learn this, it's the same rules. That's why math is actually easier once you learn it.
Mhm.
You're like, okay, it's the same goddamn thing over and over and over again. They
Yeah.
throw in more twists as you go along, but if
Hmm.
you learn the basics, the next step is easy. So this is what I was talking about. Sometimes the point they've given us is not on the x or the y axis. Where would this point that they've given me be located? Which quadrant? Where's the 3? It's on the right. It's the x value, right?
Yeah, so it's
So it's,
positive,
yeah,
so
1, 2, 3, right?
yeah, and then down one, so
Ah,
quadrant one.
okay. So it's right there, right?
Mhm.
So
Yeah.
that means if I were to draw a straight line there, that was a horrible straight line. If I was to draw a straight line there,
Yeah.
what would I know about this line here and this line here? First of all, what was the x value?
Three.
Yeah,
The
didn't I have to go
dark blue
1,
one's
2,
three,
3? Yeah, exactly.
and then the other one's down one.
Right. So what's this one?
That is, you can use the
3 squared,
3 squared plus 1 squared equals
10.
8. Yeah,
So what is this one?
10.
Almost. Remember that it's equal to hypotenuse squared. So that means the
Oh,
hypotenuse squared is equal to 10.
so 5?
No, the square root of 10 is not 5. There is
It's
no easy square root of 10, just square root of 10. So here's how you remember the easy square roots. 9, square root of 9 is 3. 4, square root of 4 is 2. Square root of 1 is 1. After
okay.
9, the next easiest square root, because 9 is 3, the next easiest one is 4, square root of 16. After 4, the next easiest one is 5, square root of 25. How do you have it so quickly? Well, 5 times 5 is 25. Therefore, the square root of 25 is 5. 6 times 6 is 36. Therefore, the square root of 36 is 6. But
6, yeah.
10 does not have an easy square root, so we just put square root of 10. However, they now want us to give us the exact ratio of sine of this angle. We'll just call this angle x, and cosine. So what is the sine? It's opposite over adjacent. So the
Yeah.
sine of x is opposite over adjacent. What's the opposite
Mhm.
in this diagram?
It is 1
Yep. What's the hypotenuse?
square root 10.
Yeah. And now I'm not going to bother writing it. You're right. You're absolutely right. So what's the cosine? If cosine is adjacent over hypotenuse, so ka,
2 over
there's
h.
no
I mean,
2. That's
2,
just a badly drawn 3.
3 over square root 10.
Yep. Same thing. Very easy. Done.
Mhm. There we go.
Now, the
Okay.
only problem is what quadrant are we in?
Uh, 4.
Yeah. Who's positive and who's negative there?
Cos is
You're
positive
right.
and everything else is negative.
So we just got to slam a negative up here for the sign.
Yeah,
Good.
good, yes.
Same answers though. It's just got to figure out the triangle. So in this case, these questions are common. You almost always get one. This is not an exact triangle, and it's not use your calculator. It's you have to
Hmm.
sort of figure out what the triangle is, and it's got its own unique exact values compared to the unit circle. And the reason it's different than the unit circle is because the radius of this circle is the length of this arm here, square
Hmm.
root of 10. So this is not a unit circle, it's a square root of 10 circle. So it has its own unique exact values.
Yes.
Okay?
Okay.
But it's still like the unit circle. It's got its own exact values. So 6, it looks like we've been dealing with a SOHCAHTOA. Sorry, not SOHCAHTOA. This is not a right angle triangle. We were dealing with sine law or cosine law in number 6.
Yes.
We just need to figure out, oh, is this one of those exceptions?
It is cosine law, eh?
We've so the rule for the cosine saw is three sides. This is not three sides. The other
Nope.
rule is side with the angle between and the side. This is not
Mhm.
this. This is angle,
No.
side angle. However, the problem, oh yeah, well, we can actually figure out the other degree here. If this is
Oh yeah.
62 and this is 38, that is
Hmm.
80.
Yeah.
Okay. That means we can use the sine law because
Hmm.
the only time we have to use the cosine law is side, angle,
Hmm.
side. That's not this. Or side, 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 which is also not this. So this is the sine law. They want
Okay.
the length AC, which is here.
Mhm.
So what would we do?
It would be sine, so it'd be 50 over sine 20 or sine 80,
Yep.
and then equals um b
Yep. Side little b.
over sine 38.
Great. How do I get that little b all alone?
You minus sine 38.
Nope. There's no minus here because,
Divide,
nope.
no, times.
Yeah. B is being divided by sine 38 to get rid of the, you have to multiply to get rid of a
Hmm.
divided. Okay.
Yes. Yeah.
So once I take my calculator and I take sine 38, okay, take sine, I multiply it by my, I think it was 50. Yeah, multiply it by 50.
Hmm.
And then divide it, hit equals, then divide it by sine of 80 and hit equals. I get this length and I just have to ask how much decimals they wanted it to. Well, how many did they want it to?
1 decimal place, so
So it's
it's just 2, eh?
what's after 2?
5. So you just
5
don't
and
you keep it?
above means this goes up.
Oh, kids is 3. Yeah.
5 and above means that number goes up. 4 and lower means it stays the same. Good.
Okay. Yeah.
That's the only answer possible. There's a one unique situation in cosine law, rather, where there's two possible triangles.
Oh,
It's when yeah, I know it's annoying. It's when they
wait. So
give side side and the angle is not related to the side side. Oh, did I lose you?
yeah, for a second there, but I'm good now.
Yeah, it's my internet. My internet's wonky lately. I don't know what's going on. Maybe the storms. So that's how you figure out that. There's two possible angles.
Mhm.
Not in the next one. The next one, we can tell exactly what law we have to use based on what they've given us. What information have they given us in number 7?
And ooh, they have 3 sides.
3 sides, which means I have to use
The Cosine S.
Yep, exactly. So I got to go to the top of my sheet, copy the cosine law that has the angle in it,
Uh-huh.
and use this one. The only tricky part is figuring out how the A relates to this triangle. Well, that's based on the angle they want. They want this angle here, so that's this
Hmm.
angle here,
Yes.
which means this is what length on that triangle?
3.4.
Yeah, everything else doesn't matter. I can put the 5 wherever I want, so I'll put it 5 as B, 3
Yep.
as C, and this
Uh-huh.
annoying 3.4 is A. And down here it's 2 times
Yep.
5 times 3. 2 times 5 is 10, times 3 is 30. So down here is 30. Up here, 5 squared is 25. Plus 3 squared is 9, 24. And then that's 25 plus 9, 34 rather. So I
Yeah.
just have to take 34 and subtract 3.4 squared. That's the only problem one. So 3.4 squared is that. So it's 11.56. So I get 25 plus 9, which is 34, minus that,
Hmm.
and I get that. 22.44 divided by the dot bottom, which is 30. With me?
Yes, I'm with you.
Okay.
Yes.
So we're going to get cosine of this mysterious angle is equal to this. Cosine of this mysterious angle is equal to this. And how do I get the angle?
So you reverse
Yep.
cosine.
I got it. Arc cosine both sides. The arc cosine on this side gets rid of the word cosine. So I'm left
Yep.
with angle A is equal to the arc cosine of that.
Hmm.
So I just leave in my calculator. I go to my trig. I do arc cosine. And I get this
Yeah.
angle. And then I just have to see how many decimals they want it to. I get angle
Okay.
A is equal, or angle whatever that is equal to this. How
Uh-huh.
many do they want it to?
They want it to 10th of a degree.
Tenth of the degree
So
is how many decimal places?
first one.
Yep. So what happens to it?
So it's 6.
Yep. And then don't forget the words degrees or the little symbol.
Yeah.
Okay. That's it for
Uh-huh.
that. Next one. Good. Good so far?
Yeah, that was good. That was
All
good.
right.
Yeah.
We're getting there. So we're past that. We're past that. We're at this. We're moving on to quadratics. Now, I had a quick look at these. A few tricks in them. I got to go back and take a clear picture. It's got a few tricks in them in that you have to expand it and factor and do all sorts of things. When they give it to you in the vertex format, right away you should figure out the easy part of that, which is the coordinates of the vertex.
Mhm.
So we're going to have a look at this angle.
-6, -3.
Yep, exactly. Now, before we do anything, which way is that facing? Down or up?
Up.
Yeah. So it's like that. And that
Hmm.
means right down here at this point, it's -6, -3, which means this graph only exists from this point upwards, right?
Yeah.
Which means its range is bigger or equal to the y value.
Yeah.
Good?
Good.
So that means this is a minimum.
Okay.
The minimum, because it's facing up. So over here we go, no, it's a minimum and it
Hmm.
occurs at -6, -3. But you should also say, all y values are bigger or equal to -3 because the graph is there. As far as x goes, the graph technically goes forever left and right. So,
Yeah.
okay, good.
Okay. Yes.
So the y-intercepts we can only figure out from when x, what is the value? So I'll do a Cartesian graph. What is the value of x on any spot of the y?
0.
Right. So if I put a 0 in here, what's 0 plus 6?
6.
What's 6 squared? 6 times 6?
36.
A third of 36 is 12. What's
Uh-huh.
you can just do that in a calculator. It's essentially when you see a fraction like this, you're just dividing whatever that is by 3.
Yeah.
12 minus 3 is
9.
9. So that means when x is 0, y is 9.
Ooh.
Make
Okay.
sense?
Yeah.
So y-intercepts are really easy because all I have to do is put a 0 in here for x and then solve. Good?
Yes. Mhm.
X-intercepts are a pain in the ass.
Yeah.
Might be possible and easier this way, though. What's the value of y, all y values along the x-axis?
0.
So we can put a 0 here. The problem is you have to know your algebra.
Okay.
BEDMAS says I have to do everything in here, but when I'm solving for something in here, I have to do the reverse.
Uh-huh.
BEDMAS is like this. BEDMAS. The reverse means I have to solve my S's and my A's first, my D's and my M's next. Sorry, my M's and my D's next. I'm writing it backwards. And my E's and my B's next. S and A stands for what in BEDMAS?
Subtraction,
Yeah.
addition.
Yeah, outside of the brackets, because the brackets are the last thing I do right there. Do I
Yeah.
see any subtraction and addition outside the bracket?
-3.
Yeah, so I should do the opposite of -3, which is
+3.
add 3 both sides is going to disappear
Yep.
here. And this
Mm-hmm.
0 is going to be +3, so I'm going to get a 3 over here. Make sense?
Yes, it does, yeah.
Okay. There was no additions. There was only the subtraction, so we're going to the next stage. Outside of the bracket, is this being multiplied by anything? Outside of the bracket, multiplied or divided?
No.
What's that third doing?
Oh, yeah, no, it is multiplying in.
Yeah, it's multiplying a third, right?
Yeah.
So it's multiplying by 1, and then it's dividing it by?
3.
That's what a fraction is. It's multiplying by the top number and dividing by 3. So technically there
Okay.
is a multiplication, but it's 1, so we don't really care about it.
Yeah.
And then it's being divided by?
3.
So what's the opposite of division?
Multiplication.
So I have to multiply both sides by 3 to get rid of this. 3 over here.
Mm-hmm.
3 times 3 on the left is?
Is
9. So I've got rid of this fraction.
Mm-hmm.
Great. Now we're into the next stage. It's exponents and then brackets. Do I see any exponents?
Yeah, 2.
So how do I get rid of a square?
Square root it.
Right, both sides, right?
Mm-hmm.
This is the only tricky spot that every student forgets. Well, this square root will get rid of the square.
Mm-hmm.
No problem. But when I do a square root of 9, the answer that every student says is 3.
Yeah.
But the problem is that it has another answer, -3. That's because if I take -3 and square it, I get 9. And if I take 3 and square it, I also get 9. So that means the square root of 3 has 2 possible answers, 3 and -3. Good?
Mm-hmm.
Tough. Yeah, every student will just say 3. That's the problem. So I'm left with this, the top one I got to solve, and the bottom one I've got to solve.
Yeah.
The brackets we're into now. We got rid of the brackets. We start all over again. What's harassing x?
6.
So I should
-6.
-6 both sides. This one I get 3 minus 6,
Which
and
is
which is
-3.
yep. So that means x is equal to -3.
Yeah.
And then down here I get -3 minus 6.
Is -9.
Yeah, so that means x is -3 or x is -9, which means the two intercepts, x-intercepts are at -3 right here,
Yeah.
comma 0, and over here at -9, comma 0. And that means they go down like this to the x-intercept of -6, right in the middle here, -6, comma 3. And up here, we figured out that the y-intercept was 9, 0, comma 9. So you'd label all things 0, comma 9,
Yeah.
-3, comma 0, the vertex, -9, comma 0. And then the max min, it's at a min here at the vertex.
Yes.
There's one other way I want to show you that you can figure this out, because that was kind of complicated, right? You need to get good at your algebra to do it.
Yeah. Uh-huh.
Okay. There's another way. It's just as complicated, but it's not as bad as algebra. x plus
Yeah.
6 squared is the same as x plus 6 times x plus 6. If we were to FOIL that, we get
Mhm.
x squared plus 6x plus 6x plus 36.
Yeah.
Okay? It would
Hmm.
all still technically be in a bracket and be multiplied by a third, which essentially means I'm, well, no, let's just, yeah, this is harder. Never mind. Ignore that. You'd have to expand it all and make it all in standard form and then factor it.
Okay.
But it's a pain in the ass. I don't want to walk you through that. This one, your teacher wants you to do the algebra on that one for sure.
Yeah. Okay.
Okay,
Yeah.
let's go to 9. This one has a little trick to it. It's the same thing we were just doing. It's just a different formula. And this time the thing is they've given us in standard form, but they want all the same information.
Okay.
But standard form means we have to use different techniques, right?
Hmm.
But I'm going to let you know that when you see it, all right, there we go. I'm going to give you the formula. First question, the easy one. The y-intercept, what's the value of x at all y-intercepts?
16.
You're close. You're jumping right to the answer. The value of x for all y-intercepts is 0. When I put
0.
0 in here, this becomes 0, this becomes 0, and I'm left with
Hmm.
minus 16.
Yeah.
Minus 16 is different than 16. So that means
Sorry.
down here, no, don't be sorry. You don't have to be sorry. I don't want you to get the wrong mark.
Yeah. Okay. Yeah.
Don't ever be sorry about any of
Okay.
this.
Yeah.
Okay, so that means I know the y-intercept's there. Is this facing up or facing down?
Yeah. Up.
Yeah, so it means it's not like that. It means it's got to have the vertex further down
Hmm.
because it's
Yes.
going through there somehow or on this side. We don't know yet. Right away, I want you to notice when you come across these things and you got to solve it. So one, we got that. We got the y-intercept minus 16. When we want to solve it right away, we should say, oh, I notice there's a 2 in all of this. 2, 2, and 2. I can
Yes.
factor 2 out of everything. I can take a 2 out of everything in there. I get x squared. This divided by 2 is plus 2x. Stop me if you don't know what I'm doing. And minus 16 with the 2 factored out is minus 8.
Yeah. Okay.
This thing in the middle now that I factored the 2 out is a lot easier to factor. I'm looking
Yes.
for what? What am I looking for?
What times is to 2 and adds to -8?
Almost. A, C, and B.
Okay, so
I want you to
wait,
remember this.
what?
It's always 8. I'm looking for something that multiplies out to AC.
Hmm.
So it's
So
1
something that
here. So it's
multiplies to negative, positive, -8.
and adds up to.
2.
Yeah, so you got it in reverse. It's always going to be adding up to this number and multiplying out to this
Yeah.
number. But here, see, if we kept the 2 in, we'd be looking for 32. It makes it harder. What are the
Yeah.
factors of 8? 8 and 1.
8 and 1. 8 and 2. Wait.
Not 8 and 2. 8 and 1 is one of
No.
them.
2 and 4. 2 and
Right.
4. 2 and 4.
It has to be negative. So one of these has to be negative. Either negative
Yes.
1 or negative 8. Does 8 and 1, if it's negative, ever add up to 2? No matter which one is negative?
No.
No, so rule that out. This one looks
Mhm.
like it could add up to 2 if one of them was negative. We're trying to
Yeah.
add up to positive 2. Which one's negative?
Uh, 4.
If this is minus 4 plus 2, what do I get if I add them? Minus 4 plus 2.
-2.
Yeah, this is positive 2 for B.
Oh, so it's reverse. So -2,
Right, so my
4.
answers here are negative 2, positive
Yeah.
4. And because I've made this into 1, because there's 1 squared here,
Hmm.
because it's 1 squared here, I don't have to do any grouping or anything. I can just write it like this. 2
Mm.
x plus 4, x minus 2. If I wasn't sure that I got the right thing, I could expand it and see if it comes out to this here.
Yeah.
It does. And that tells me my x-intercepts. What are my x-intercepts?
4 and
Almost.
-2.
So it always does the opposite in there.
So positive, -4, +2.
-4 comma 0. Yep. And +2 comma 0. If you ever wanted to prove it to yourself, plug in the 2 here and see if it all comes out to 0 because y is 0 here. Or
Mm-hmm.
plug in the -4 into here and see if it comes out as 0. It should because y is 0 at the x-intercept. Good?
Yes, good.
The other way is, what is the value of y at the x-intercept? What was the value of y?
0.
Yep, so over up here, instead of fx, I can just put in 0. Reverse bedmass, is there any addition or subtraction?
Addition
Yeah, so there was
and
subtraction. So how do I get rid of that
subtraction. Yeah.
-16?
+16.
Okay, so I get +16. So I get 16 is equal to this. Just this this left half. Good.
Yep.
Notice that I can, let's see if this is doable. I can factor a 2 and an x out of this left side, or this right side, can I? A 2 and
Yes,
an
you
x.
can.
And I'd
Yep.
be left with what? If I divide this,
X
yeah,
plus 2.
yeah, x plus 2. Great. So that means, let's see if this works. No, that doesn't work at all. So I don't think I can do it. Like, I'd have to divide everything by 2. So I can't do a factoring. I can't do it this way. I have to do it the way we did it. Good?
Yep.
Just ignore everything I did there. If it's not equal to 0, you can't solve it like that.
All right.
So we figured out the y-intercept. We figured out the x-intercepts by factoring. We could have factored it this way too. We could have said what multiplies out to -32 and adds up to 4. What did I do there? How did I get this from this?
Mm.
What do I always put at the top here? What letters?
2 and 16.
Yeah, it's A and C. A represents this number. C represents this number. 2
Yep.
times -16 is -32. B is always this number, B. This is a little harder. The two numbers that I'm looking for are, it's not as easy. It's, let's see, 16. So it's 16 and 2. That doesn't work. 8 and 4. That's the number I'm looking for. 8 and 4. This is positive, so this is negative. So the two numbers this time are 8 and -4. But I'd have to group. I'd have to do 2x squared plus 8x minus 4x. Practice your grouping because this comes up -16. This is a lot harder, right, than just factoring the 2 out.
Yep.
Right? So if you want to go through grouping, you can. You'll get the same answers, but it's a lot harder. You got to remember how to group. I still suggest you practice grouping because your teacher will do this. Here's the hardest part of this question, though, right?
Okay.
Here we go. Skip everything we did. We figured out everything. It's a maximum, by the way. We just don't know. Sorry, it's a minimum. We just don't because it's aiming up.
Yeah.
We just don't know what because this is hard to figure out the coordinates of the vertex. What do I do to figure out from a standard form? What did we do a lot? I kept saying complete the
square.
Yeah, I got to move the -16. I
Yep.
got to factor out any number that's here. What's the number?
2.
Yeah, if I factor out 2, what am I left with?
Squared plus 2x.
So I should factor, yeah, x squared plus 2x. There you go. You got it? At
Yeah.
this point, now that the x squared has a 1 in front of it, I can half this number. What's this number?
1.
Right. So I can do x plus 1 squared. Good?
Yep.
I have the -16. The only problem is because there's a 2 in front. First, I have to subtract the opposite of what would this be squared? What's 1 squared?
Just 1.
Yep, I have to subtract 1. But to get it outside with the 16, I now have to multiply it by this 2. What's 2 times -1? So you always have to subtract whatever this is
-2.
squared, and then you always have to multiply. Yeah, so to get it out here, I get -2. I've gotten it out now. What's minus 2 minus 16?
Um, -18.
Yeah. That means the vertex is?
-1, -18.
Right. Now that I figured the vertex, I know it's facing up. This is the minimum. Good?
Yeah,
So
good,
we
yeah.
gotta practice two things. Practice your factoring with grouping. Factoring
Hmm.
with grouping because you had no idea what I was going at there. And you gotta practice your completing the square. It's the
Yeah.
only way you're gonna get to the vertex. But there's a little cheat. At this stage, the toughest part is figuring out the numbers outside over here, right? But this
Yeah.
stage here was pretty easy. What's the x value of the vertex here?
1.
Almost.
What? Oh, -1. Yeah, yeah,
Right?
yeah.
So if I take it up here and I put wherever I see x -1, what's -1 squared?
Just -1.
No, -1 times -1, two negatives multiplying become
Oh, positive, positive,
positive
positive.
1 times 2 is?
Is 2.
Okay, -1 times positive 4 here,
-4.
right? And then -16. Add those up for me. 2 minus 4 minus 16
2 minus 4
is minus 2.
minus 16.
Minus,
-18.
there, we figured out the y value of the vertex without doing all that
Yeah.
expansion stuff. So once you figure this part out, it's kind of easy to go back and figure out this,
Okay.
right? If you're in doubt if you got it right or not.
Yeah.
This is called partially completing the square. It's very
Mhm.
easy. We get the x value of the vertex and plug it back into the main equation up here.
Okay.
Good? It's a good trick on a test because you can verify if you got the right answer or not. Last question on this page. We might as well do it. You good?
Mhm.
All right. You still alive?
Yeah.
Okay. This is a standard question. It seems impossible. This is the generic formula, in other words, with no numbers in it, of the vertex format. However, they've given us the vertex right there. Okay.
Yes. Yeah.
So normally this would tell me the vertex of the x, and this would tell me the vertex of the y. The reason they put the negative here is to tell you it's the opposite of whatever this is. That's why they put the negative number here. They're just saying, remember, it's the opposite of what you see. What do you see there?
Yeah. -2.
So what's the opposite of -2?
+2.
So what should be in there?
+2.
Right. So we can right now replace that with +2. This is exactly as you see it here. So we can replace k with
3.
3. The only
Yeah.
thing that's a mystery is that weird a. And you might say, well, why, how do I figure that out? Because sometimes, right, we have to factor out a number. Sometimes that number exists. You say, well,
Mhm.
how do I figure that out if I don't have it? Well, that's always ask yourself, why did they give me more information? This is another x value and another
Mhm.
y value, which means I can, wherever I see y, I can put 11. And wherever I see x, I can put 2. So that means I can
Okay.
rewrite this equation and I can put the new number they gave me, 11, where I see y, which is here,
Yep.
and where I see the x, which is right there, I can
Mm.
replace it with this 2.
Okay.
Whoops, almost. Okay, what's 2 plus 2?
4.
Yeah, what's 4? Remember that we have to do inside the brackets first. So 4 is 4 squared. You have to go in
Yeah.
bedmass order, which means exponents next. 4 squared.
16.
Right. So I've got this weird thing, 16 times a plus 3 is equal to 11. I've got to solve for a, which means I have to do reverse bedmass if I'm going to solve for a.
Yep.
That means that,
So
yeah.
minus 3.
Yep. So I got 16a is equal to 8.
Yep. And then you want to divide 16?
Yep. So I got 8 over 16, and those can both be simplified. This can be divided by 8, becomes 1. This can be divided by 8, becomes 2,
Half.
which means
Yeah.
a is a half. So now I can put it in over here. Very common question. You'll almost always see a question like this.
Okay.
Good.
Good.
This is just redoing it. They're giving us a new vertex, so we put it in there. And this looks like a trick, x-intercept, except what's the y value at the x-intercept?
4.
No, that's the x value.
Oh, okay.
What's all y values at the x-axis?
0.
So that means when they tell me this, they're actually giving me the 0.40. I would put the 0 there and the 4 there and do the same solution with this new vertex. Do you know what I mean? Okay, let's try it.
Yes.
Let's just try it. Here's the I'll go through it really fast, okay? Here's the generic. We're going to put it down with this, and we're just going to focus on this one. It's like doing the same question again, but they're being tricky. What's the vertex they gave us?
-1, 5.
Yeah, so you're jumping ahead of me, so I would put -1 in here, you're right. And I would put a 5 here. We can't solve it because we don't know A, except they gave me a new point. You might say, well, they just gave me 4. But no, when they give you the x-intercept, it's 4, and it's the
And
y
0.
value is 0. That means I can put the 0 here
Mm-hmm.
and the 4 wherever I see x. So I can rewrite my equation, and I can say, okay, here's my y is this side, 0. And I can see it's 4 goes here where I have x. What's 4 minus 1?
3.
What's 3 squared? 3 times 3.
9.
So I got 9a plus 5 is equal to 0.
Yeah.
What do I do? 9a. I'm trying to solve for a.
minus 5.
So I got 9a is equal to minus 5.
Mm-hmm. And then divide 9.
That's right. And it can't be simplified. So that means a is not minus 5 over 9. So the full formula is minus 5 over 9, x minus 1 squared plus 5.
Mm-hmm.
Good?
Good.
A lot of rush. I'm going to send you the video. You can play it back. That's the first 2 pages. That's pretty good. Practice. 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 Decide what mark you want. The more you practice, the better your mark.
Okay, yes.